Again, from the Larsen 8.9 worksheet, here's number 10. And this is our function h of x equals 1 over 2x minus 5. We want our center to be 0, so that's nice. We just have to have a x. So we just reverse these, use the commutative property. And we put the 2x to the right and the negative 5 to the left. And we've already got our x here, so we don't have to do too much with this. But we need to make this to be a 1 so it's in the right form. So I'll divide everything by negative 5. So negative 1 over 5, negative 5 over negative 5, and 2 over negative 5, or negative 2 over 5. And this becomes a 1 now, so we can see now we have this in our form. A is going to be negative 1 over 5, and this is negative r, so that's going to be negative 2/5 x, so 2/5 x is r. We can find our interval convergence. Remember, we want the absolute value of r to be between 1 and negative 1. That should be negative 1 over here, excuse me. And I just multiply everything by 5 over 2, negative 5 over 2, 5 over 2, and there's my interval convergence. And it's got a little bit cramped in here, so because I put extra steps in. So if we sum this up, we use our form a r to the n. There's my a, negative 1/5. There's my r, 2/5 x to the n. And I can take out the negative sign, so I got 1/5, and I can raise 2 to the n, x to the n, and 5 to the n. And if I do that, again, as we've done in some previous problems, 5 to the n times 5 to the first power is just 5 to the n plus 1, 2 to the n, x to the n. There's our negative sign that we factored out, and there's our interval convergence. So I got that kind of cramped in there, but hopefully that all makes sense. Okay, and number 11 is very similar. I think I can fit this in, so let's take a look at number 11 also. And 11, another center 0, so this is nice. These are a little bit easier. It's not so much work to do. So 3 over x plus 2, so 3 over 2 plus x. And we've already got our x all set, so we don't need to worry about that. Right now, we can take care of the SIG in just a second, but we need this to be a 1. Oops, I have to put my forms over here. Remember, a over 1 minus r, and then our summation. Just so you know those things are going on. Okay. So we need to get this to be a 1. So I'll divide by 2, by 2, by 2. And this gives me 3 halves on the top, and this is my 1, which I have this in my nice form over here. Okay. And then x over 2. 2 over 2 is 1. So there's my a. And remember, it's going to be negative r, so I just change this to a double negative to make a positive. And I've got minus r. And my r is going to be negative x over 2. So there's my a. There's my r. Again, we can find the interval convergence. We know that r, the absolute value of r, which is just, will be less than 1. So the absolute value gets rid of the negative sign right away. And so x over 2 would be between 1 and negative 1. So I just multiply by 2, and there's your interval convergence. And we put this in our summation form, a r to the n. My a is 3 halves. My r is, over here. A is 3 halves. R is negative x over 2 to the n. And I can write this as 3 over 2. Now, with the negative sign, we could take that out as negative 1 to the n, if we want. And x to the n, all over 2 to the n. And if we do, like I said, you could have left it with a negative x on the top also. I think there was a different way to do this. You'd write it like this also. Sometimes we like it in this form. Okay, especially when we're taking derivatives. Okay, so we could factor the 3 out, but I can combine the 2 with the 2 to the n. So I can take 2 and make that 2 to the n plus 1. There's my negative 1 to the n, there's my x to the n, and this is a 3. So this is a nice form. I think the answers I gave you also had this form, where they actually did take out this, they took the 3 halves out, and they left it kind of in this form, minus x over 2 to the n. But like I said, I think I like this form a little bit better, especially when you're taking derivatives or antiderivatives. This would work a little bit better, I think. Okay? And then there's your interval convergence. But any of these answers would be correct.